Welcome to this video. This is lesson 4. We're going to talk about inverse variation of Unit 7 rational functions. Let's get started. Our agenda, we will cover the definition of an inverse variation. We will talk about a real-world example of it, and then we'll do some practice problems, and I'll leave y'all with the IXL work to do on your own. Our objective, scholars will be able to determine the unknown value of an inverse variation equation. And of course, I'm going to talk about what that means. And our big idea is still rational functions. Here's our guiding question for this lesson. In which of the situations below would my speed be greater? If I traveled 60 miles in 1 hour, or if I traveled 60 miles in 5 hours? You probably guessed correct. It's the first option. In other words, if my time is low, my speed is high. And if my time is high, my speed is low. That is an example of an inverse variation. So inverse variation is really just a rational function, a special rational function that we've named. And it looks like this. Y equals k over x. Now k is just a constant. So we're talking about a number, 1, 2, 3, or some decimal, divided by x. And we can actually rewrite this by multiplying x on both sides as x times y equals k. This is the rational function known as inverse variation equation. This rational function is special because it models real-world situations very well. You can think of it as kind of like a give and take. For example, when x goes down, y goes up, and vice versa. So suppose it takes 12 workers 4 days to construct a house. How long would it take 16 workers to complete the house? Would it take less or more? You probably could guess that it would take less days if you have more workers. So more workers means less days. Less workers means more days it would take. So you can see how it's inverse. One goes down, the other goes up. So I'm going to go ahead and say out front that these questions are very easy. So you're going to have a great time doing IXL. I expect everyone to get an 100. Here's how you solve these types of questions. Step 1, determine the value of k. Step 2, use the value of k to write the equation. And then step 3, use the equation to solve for unknown values. Alright, so this says an inverse variation, y equals 1 when x equals 8.2. Write an inverse variation equation that shows a relationship between x and y. So step 1, we need to find the value of k. K is just going to be equal to whatever is x times y. So in this case, that's going to be 8.2 times 1, which is just 8.2. Now step 2, use the value of k to write the equation. So we just write xy equals 8.2. And that is literally all you have to do. On this question, we're going to go one step further and do step 3. So we're told, assume that y varies inversely with x. If y equals 8 when x equals 4.2, find x when y equals 5.6. So step 1, let's determine k. K is going to equal x times y, and we're going to use those first two values. So that would be 8 times 4.2. That is equivalent to 33.6. So we know that's our value of k, and we can now write the equation. But this question asks us to go to step 3, which is to use the equation to solve for an unknown value. We're asked to find x when y equals 5.6. So we're going to say, what is x when y is 5.6? So we're going to do x times 5.6 equals 33.6. All we need to do is divide, and we get our answer is that x equals 6. And that is it. That is our final answer. Alright, that was all the problems that we're going to try. If you want more of a challenge, and you felt like this lesson was too easy, check out the extension activity titled Inverse Variation Extension Problem. Try that one out. The IXL for you to do is Algebra 2 Q2. Please be sure to send me an email or join me during my office hours every day 2 to 3 p.m. on Zoom if you have any questions. Best of luck.